So we have the integral from 0 to pi by 6 of tan squared 2x. Now there is an identity that says tan squared a plus 1 is equal to sec squared a, or 1 over cos squared a if you like. So that means that tan squared is sec squared minus 1. So we're going to have the integral from 0 to pi by 6 of sec squared 2x minus 1. So sec squared integrates to tan. So we're going to have tan of 2x divided by 2 because of the reverse chain. Take away x to be evaluated from 0 to pi by 6. Which gives us tan of pi by 3 over 2, take away pi by 6. And the bottom limit here of 0 will just give us 0. And tan of pi by 3 is root 3, so it's root 3 over 2, take away pi by 6. So we want to integrate sine cubed 2x. Now, when you deal with odd powers of sine, split them so that you've got sine and you've got sine squared. And then you're going to use the fact that cos squared a plus sine squared a is 1. So the sine squared can be written as 1 minus cos squared. So we've got sine 2x and we've got 1 minus cos squared 2x. So expanding that out, we've got sine 2x, take away cos squared 2x, sine 2x dx. Now sine integrates to negative cos, so that is going to be negative cos 2x divided by 2, don't forget the divided by 2. And this one's going to end up being plus cos cubed 2x over 3 times 2. The 3 is because of the increase in power, and the 2 from here. And I don't know why I've got the square brackets, we haven't got limits. And we've got plus a constant, so that's going to be negative cos 2x on 2 and cos cubed 2x on 6 plus a constant. Now this next one's incredibly simple if you spot it. What we need to do is write it so that it's 1 over x on top and ln 2x on the bottom. And if you differentiate ln 2x, you do get 1 over x. So it's an integral of the type f dashed x over f of x dx, which always gives us the natural log of the modulus of the denominator. So this one is ln mod ln 2x plus a constant. Okay, this one is a bit of a beast. So we've got x is equal to 3 sine u, therefore dx du is 3 cos u, so dx is equal to 3 cos u du. So we can replace the dx. Now x is 3 sine u, so x squared would be 9 sine squared u. Then you've got to multiply by 4, so that's going to be 36 sine squared u all over the square root of 9, take away 9 sine squared u, and the dx of course is 3 cos u du. So we've got 36 sine squared u. Now this will end up being 9 cos squared u because of sine squared plus cos squared being 1. Square root it, that's 3 cos u. And so those two cancel out. And so we've just got 36 sine squared u du to integrate. And of course, that actually requires a trigonometric substitution. We know that cos 2a is 1 minus 2 sine squared a, which gives us that sine squared a is 1 minus cos 2a all over 2. So our integral is going to become 18 times the integral of 1 minus cos 2u du, which is 18 u, take away, minus cos, minus cos would go to minus sine, so it is minus 18 sine 2u over 2 plus a constant, so that's 18u, take away 9 sine 2u plus a constant. Okay, so I'm just going to change colour actually for this next bit. So we know that x is 3 sine u. So I know I've got another page to work on, but I want to keep this all in sight here. So that means that sine u equals x over 3. So our u is going to be the inverse sine of x over 3. So that bit's pretty straightforward. So this one is going to be 18 inverse sine x over 3. Now the 9 sine 2u. So let's think about that. So I know that x was equal to 3 sine u, and the expression I've got here is 9 sine 2u. So sine 2u is 2 sine u cos u. So I've got 18 sine u cos u. Now the sine u is easy enough. That's x over 3. What about cos u? Well, x squared is 9 sine squared u. So that's 9, 1 minus cos squared u. And so x squared is going to be 9, take away 9 cos squared u. So 9 cos squared u is going to be 9 minus x squared. So cos squared u would be 9 minus x squared over 9. So cos u would be the square root of 9 minus x squared over 3. So that is going to be root 9 minus x squared over 3. 3 times 3 is 9, so those will cancel that down to 2. So I'm going to end up here with 2x root 9 minus x squared plus a constant.